I'm just going to do the demo right away, get that out of the way. Although I just tried it once, you probably already saw it. So I'm Jason Huggins, creator of Selenium, co-founder of Sauce Labs, and creator of robots that play Angry Birds. So I'm just going to go right into the demo, and then I'll give you the story of why I created such a thing. So here we go, drum roll. This is kind of a semi-automated testing. All right, here we go. I think this is going to work. There you go. Nice. There we are. All right, so title of my talk, Building a Robot That Can Play Angry Birds on a Smartphone, or Robots Are the Future of Testing. The third, perhaps, subtitle for this would be What It's Like to Live with Adult ADHD. You should follow me on Twitter. I'm HUGS. Can you hear me in the back okay? Yeah. So the name of this project is Bitbeam, and I'll have the URL at the end. It's bitbeam.org. And if you're at, who here was at the Jenkins conference in October? Okay, 2, 3. Got it. So should definitely come to the next one. This was the robot, the Angry Birds playing robot that I actually showed off at Jenkins Conf in October. The funny story about this is that all the circuitry, everything kind of came together like about an hour before my talk. I was still blowing circuits and running a Radio Shack very, very soon before my talk. But I got it all working. This kind of design is, you would call it a 3-axis CNC machine with 3 steppers, and kind of sort of looks like a MakerBot. Anyway, this is the first thing. So this is this talk is my follow-up basically to the Jenkins Conf that I gave in October. But there's a huge story to why I did such a thing. Who here remembers the Sony Aibo robotic dog from like 1998 or so? I hope lots of people do. Okay, maybe about half the room or so. So 1998, I just graduated from college. Robots were everywhere. Legoland California just opened. Lego Mindstorms just came out. Sony Robot Dog came around. And there was this robot fever, I guess, was sweeping the country. And this is actually the second time in my life. I remember, early 80s, also robots were sweeping the nation. Anyway, I thought I had this idea that I'll let Sony own the land animal robot market, and I was going to come up with this idea for robotic fish. I thought it was a wonderful idea. You have dentist's office with aquariums, but all those stinky fish, you have to clean the tanks, but if they're robots, you never have to clean them. Maybe they're solar powered, never even have to change the tank, whatever. Perfect idea. And then you had bath toys and pool toys. It was perfect. The problem was I knew nothing about electronics, I knew nothing about mechanics, and especially knew nothing about how to actually make all this stuff work underwater. Totally screwed. I was really serious about this. I think I registered the domain roboticfish.com. The company name was going to be Aquatic Robotics. I thought that was actually kind of a fun little pun. I think that's gone. I let that one go. I even went to the Shedd Aquarium in Chicago and studied how fish swim. And I learned that they swim in a sine wave motion. I got all the books, watched them. If you watch like an eel swim, it goes almost in a perfect sine wave. This is how their fish are so efficient in the water. You see like a big tuna or something, they kind of waddle along, or a snake crawl in the grass, but it is in a sine wave motion. So I started modeling sine waves, trying to like figure out, okay, if I needed, even though I didn't know how to do any of this stuff, I didn't let this stop me from doing some software models for this stuff. Created some 3D simulations in Excel. I don't have screenshots of that, but while I was doing that, I became more fascinated with this animation of just seeing sine waves work. And meanwhile, while I was staring at my computer screen, I had one of these things called pin art on my desk. Most people familiar with pin art? Have you seen this? It's kind of a toy from the 80s. And I thought, here I am doing 3D simulations where all these little bars are going up and down, and I've got this static pin art sitting on my desk. So I came up with a cooler idea than robotic fish. What if I motorized every single one of these pins? That would be awesome. Problem is, I came up with this idea maybe 1999, maybe a year into my robotic fish odyssey. I'm still looking for an actual business use for this thing. So I joke it hasn't passed the wife test, as in like, hey, honey, I'm going to quit my job and just work on this. Like, no, that testing thing, there's a business model there. So hasn't passed the wife test yet. But I'm still been working since 1999, actually, on this motorized pen art project. And you kind of tackle it from 3 different angles: the software, the electronics, and the mechanics. And the first thing I did was tackle it from the software, being a software guy. So if you go to pinthing.com, you actually type in show 1, that will show it. The idea was, instead of doing an entire array like this, I was going to start small, maybe create small little packages you can show numbers, and then get 4 of them you can show a clock. So, good idea. However, that was, I think, maybe 2003, 2004. I've been stuck in the software side, but meanwhile, I had to learn the electronics and mechanics. Around 2007, 2008, I think that's when I really started playing around with the electronics. I'm actually, in Arduino, very comfortable with that now. Finally got to the hardest part. It's like 2009, 2010 was the mechanics. But 2010 was when I went to the Maker Faire in Bay Area and met Phil, I think it was actually the Jenkins brothers. They have this project called GridBeam. They've been working on it for a while. But this is kind of like adult-sized erector sets. They can build cars. They actually build electric cars and shelves. And actually, it's really trendy around here. You could build a standing desk out of GridBeam. I bought the GridBeam book at the Maker Faire, and I thought this is cool. I put it in my shelf and didn't really think of it. But I thought it was a cool project. I'm still looking to build some shelves or something like that. If you've ever been to IKEA and have like the IVAR, shelving system, it's kind of like that. It's pretty much like, adult-sized erector sets. And these beams are made out of steel, but you can make them out of all kinds of different things. Then a year later, or 2, I guess. No, a year, because 2012. I went back to kind of try and prototype my motorized pin art, and finally got it down to this model. Actually, here it is, right here. I call it the clicker. This is the fancy phrase would be linear actuator. And usually you can buy like a linear actuator for like $100, but I need like 1 billion of these for my project. So I prototyped in Lego and it worked. The thing was, I priced out, okay, if I wanted to do 10,000 of these things, that was going to be way too expensive. So I figured I was going to grow up, port this to real materials like metal, aluminum, acrylic, or something like that. And then and it was basically a whole step backwards. Everything that was working in Lego, now I had none of the geometry. I had to basically recreate everything that was working in Lego. So they had the idea, and then I remembered I had that GridBeam book. So I picked the GridBeam book off the shelf and had this idea, like, well, if I take all the principles of GridBeam but miniaturize it down to Lego size, then I'll have miniature GridBeam, or we call it BitBeam. And I then spent half a day porting basically my little linear actuator from Lego over to BitBeam. Of course, I had to go learn how to cut wood at Tech Shop, San Francisco. So spent a while over there learning how to laser cut. These are actually out of wood. I've been surprised that people have been surprised that this is basswood. But yeah, it's wood, laser cut at Tech Shop. So I finally had my clicker. And this is where this thing kind of gets back to like, okay, where are you going with this? It has nothing to do with software, Jenkins, Selenium, whatever. Well, here I am. I finally have my linear actuator. And here it is in the array of what it might be. Imagine, again, that's that clock, 5 over, 8 down. Sorry about that part. And imagine it goes out infinitely in different directions. So I could, at some point, have these long pins. I could render like the Grand Canyon. Imagine kind of like Google Earth, but in 3D, kind of a thing with a 3D thing like this. But as I'm playing around with this, walking around the house, finally have this miniature GridBeam, my Lego thing, I'm off to the races building this. I turned it upside down. I was like, hey, wait a second. This is kind of like maybe I could put this over a phone and I could click buttons. It's like, man, I know a thing or two about clicking buttons. This might actually be useful for clicking buttons. So I went around the room, tried to find stuff that I could put on here to see if I could, send a touch signal to iPhone, and ... here we are today. So it started from a project where I wanted stuff to go like this, and then I just put it upside down, and all of a sudden you now have a robot that potentially can play Angry Birds. Welcome to my brain. So this is the BitBeam bot. What you're looking at now is generation 2, and it's the Angry Birds playing functional testing robots. I had to scratch out Selenium powered because I'm still getting there. That's the intention. Not there yet. Version 2. So what is it actually? It's computer-controlled robots, and it really is these things. The electronics are Arduino. The mechanics are my, for lack of a better phrase, open source Lego / erector set. So my side hobby is now going to be crushing Lego and bringing them down, killing them with open source. You heard it here first. And it's made from basswood, which is a slightly harder version of balsa wood. Most people know balsa wood, but if you go to the balsa wood section of the store, you've got balsa wood and basswood. And basswood's actually what you probably want to have. I designed it with a tool called OpenSCAD, and like I said before, I cut it at the at Tech Shop San Francisco. The software is mostly Python on the laptop, and then I use the Arduino. That's just C code running on the board. Like I said, in future versions, I'd like to have this be kind of like a supported browser in Selenium, where browsers are implemented in different kind of languages, but you'd basically be able to say, run iPad with robots or something like that. So you can actually a specific desired capability of testing your iPad, but hey, assuming a fancy contraption sitting on top of it. Yeah, so why did I do this? I realized through this project, actually building this real robot, that Selenium is just a robot. It's just locked inside a 2D screen. And the things that you have to do to get Selenium to do stuff is very similar to how you would have to have a real robot interact with the world. It really comes down to two things. You have to find elements, and you have to do something to them. In the real world, you would have, it's mostly vision-based, and we've got a whole bunch of different ideas for that. The kind of hybrid, bringing it back to Selenium, really what I'm trying to drive towards is perhaps a new locator strategy. The Sukuli project, if people are familiar with the Sukuli project, a couple of people, it's a really cool project. I'll have to be nice since this is on camera, but it's better than manual testing. It's the worst way to do automated testing, but hey, it's somewhere in there. It's still very cool. Definitely passes like the geek cool factor. What I would like to do is add a new locator strategy to Selenium. So you have like CSS selectors and IDs and XPaths. Don't use XPath. And a whole kinds of different things. I would like to add like select element by PNG file. And it could either take a screenshot off the screen, or it could take it off of video out from a device. So that the project is bitbeam.org. It's where I'm kind of blogging this stuff. So I do have a couple other demos that I want to show you. We did see that the robot can play. One of the frequent questions I get is, okay, how the heck did you do that? If you look at the throw commands implementation, it was all hard-coded. Kind of a ghetto testing way to do things. Let me move the video out here so it's not distracting. The other kind of goal of what I'm trying to get to is I have the robot and I tell it commands. The thing I need to learn, the very fancy phrase, is inverse kinematics. If anyone knows that, I would love to talk to you. That's how you convert like X, Y coordinates, and you tell the robot how to get to a particular location. So that's kind of like the output. The input, I would like to use the computer vision OpenCV project, and I have a demo of that I'll show you, where we use computer vision to see what's on the screen, then do something like find element by a PNG file, and then find it, and then use that XY coordinate to tell the robot where to go. Like make it a complete closed loop, so I don't have to sit here and type commands. The robot can basically play by itself. So I have this little program, and it's searching on the screen for this little PNG file. All right, Terminator Vision. All right, let's see if I can. Let's see if this works. I wonder if it's going to be too loud. See, there you go. It found it, and if I move it around a little bit, it still finds it. So while it's moving, it doesn't find it. Let me bring that window up again. Oh, come on. Where is he? Oh, it's right there. There you go. Come on. Oh, forget it. Anyway, you can see that it's on there. I can find the XY coordinates. Actually, I'll just do this. I'll do that. So it's found location, moved over, not found while it's kind of moving around, then found it again. That is an XY coordinate. So I started with a PNG file, I now have an XY coordinate. The cool thing about this is actually Selenium 2 works kind of in a similar way, where we actually ask the browser, we decouple basically the finding things and doing things to it. With Selenium 2, we ask the browser where the element is. We use JavaScript or a bunch of different ways to find where it is, finally get to an absolute XY coordinate. And then we ask the operating system to actually click on it. So I'm hoping that I actually can abstract out, and instead of asking the operating system to click on that XY coordinate, I actually use my robot to click on that on the iPad screen. So there's a little bit of kind of just like understanding all the different little bits and pieces of the project and separating them out and putting them back together. That's what I'm learning with this project. So that's kind of the computer vision aspect of it. Let me show you the code really quick. It's kind of cool. It took me about a month to figure out how to install OpenCV, and then about like an hour or two to figure out, just Googling around, Stack Overflow is awesome, Google is awesome, and figure out how to actually get a sample to work. So here I am importing or bringing in the redbird.png file that I'm looking for. That's the template. This is a threshold, which is just trial and error, just whatever. There's a certain level of has a kind of a confidence factor, a fuzzy level of confidence, whether it can find it or not. So that's just the number that I found when it did find it. I kind of pulled that number out. I'm calling out to, I'm using this device called, amazingly named VGA to USB. And it takes VGA and then exports it to USB. It's by a company called Epiphan, and it's pretty cool. I haven't figured out how to actually read the raw files yet, so I'm actually kind of doing, again, kind of a ghetto kind of API call. I'm just calling it as a separate executable, and it dumps a frame, a bitmap file to the file system. I then open that using the capture from file method, and this is where things get fun. More specifically, this is where pretty much all the magic is, actually, the match template. That's the magic incantation. I don't know anything else other than how to call this method. It got it to work, and then there's a whole bunch of stuff, computer vision. I think I'm actually specifying which particular algorithm to use, like square diff is my guess. Beyond that, I have no idea. And then I do some fun stuff. I originally had a rectangle, and I figured it might be more fun to replace that with a crosshair, so I got that working today. Show 2 lines in a circle, and if not, if you can't find it, then and anyway, it grabs a frame and then displays that to the screen. So that's the software. So I'm coming out from 2 different angles. I have the open computer vision and got some early demos for that, and then I've got the Arduino. But of course, it's kind of hacky because I don't have inverse kinematics implemented for the Arduino, and then I don't have really anything fancy for the OpenCV stuff. It's still kind of, what you see was what you get right there with that code. One of the things I also learned with trying to actually now try to bootstrap, improve the OpenCV stuff is, wow, why the heck did I pick Angry Birds as a first project, or first game to do this thing? So I figured, okay, I need to kind of make this a little bit more simple. So I have just one other demo, another app. I figured, okay, maybe I should start with something kind of a painting program, maybe draw a box, start with something kind of simple. Figured, okay, but I still want to stay in the games department here. So I'm going to do Tic-Tac-Toe. So let's see if we can kind of come around here again. I'm going to have to calibrate it. Any questions while I'm setting this up? Throw it out there. Calibration technique, very fancy. See if I can click it into the middle. I'll see what happens. That's pretty good. All right, okay, so let's try this. New game. I have wonderfully good at painting methods. One. Right. So does anyone remember war games? play that are simpler than Angry Birds, going to realize, wow, that's a ridiculous idea. And then as I build up skills, then I can eventually play the rest of Angry Birds, maybe get to 3 stars, or stuff like that. So that's what I wanted to show you. I'm amazed it actually worked, so I'm just going to stop, collect my winnings, and open up to questions. So thanks. You know, I occasionally heckle them on Twitter. I follow them. And I am just not cool enough or something. So if you got somebody, a friend at Rovio, I would love to say, hey, check it out. Although, right after I did this for Jenkins Conf, I was super excited. I actually thought I was the first human on the planet to create a robot that played Angry Birds, because safe assumption. I was crushed because both a month before the Sakuli blog, I had no idea, but like in August, Sakuli also has a script on how to play Angry Birds. So that was crush moment number 1. And then there's a company in like Norway or Finland or something like that, Opto Fidelity. They also, when I Googled, this is where I was crushing, when I Googled Angry Birds playing robot, I figured I was going to have 1 million hits. No, all the top 10 or 20 or whatever was Opto Fidelity. I think they do design testing, like for like Nokia. Like I'm sure every single phone manufacturer has some secret lab where they have this robot, but because of trade secrets and patents, I hope not patents, but all kinds of stuff, these are all competitive advantages and no one wants to talk about it, except for this one company, which I'm sure is probably an outsourced third party that does screen testing. But for fun, they did this huge human versus robot Angry Birds playoff thing. There's very high quality YouTube video and just totally crushed. So now my mission is to get to be the top post for Angry Birds playing robot by talking about it. So it's kind of a war of attrition now. They just did the one thing. But
you're the first American, so in my eyes, you're the first.
Exactly. There's a little bit of a Wright Brothers Langley kind of a thing there. When Langley lost out to the Wright Brothers, he just gave up. But I'm not going to be like Langley. I'm going to keep on going until, I guess this can fly apparently or something. I don't know. But there's a, even though I wasn't the first, it's still fun. So there's still honor. Right. Ooh, in space? Oh yeah, if you have a connection with NASA. Also maybe arm wrestling, thumb wars perhaps. Anyway, yeah. I actually started, when I started with this thing, 1999 or so, I actually started with Basic Stamp. I got the Basic Stamp starter kit from Parallax and just had fun with that for a couple years. And then when Arduino came out, I switched to that. I haven't needed to go any farther than that. I mostly have a very simple program. Maybe I can show you, but I don't want to waste time pulling up. It come afterwards. The software to control the microcontroller is so simple. All I'm doing is sending like raw command. I've got a 2-byte protocol. You know, which server I want to talk to is byte 1, and the second byte is the value between 0 and 180. Yeah. So I've got there's kind of a lot of philosophies there. One, I just like the Arduino community. It's simple. I love it. It's like Lego and all these different things. They're just good building blocks. The other thing is I believe in keeping the laptop very smart and the Arduino very dumb. Because if you have to compile and send it every time, I'm very much brain damaged in the way of needing an interactive prompt to do stuff. I can't deal with compiled languages. It's too fast, even if it's 30 seconds to compile and send it over. So if I can keep all the code in Python, then I can very quickly iterate and just keep a very simple protocol running on the Arduino. So I've never needed to really get much deeper. However, this Epiphan VGA to USB thing is like $300 for like 8 frames per second. If I buy for $700, I can get the 30 frames per second thing. Meanwhile, there's all these cool projects like BeagleBone and the Arduino that runs from ARM, the Arduino, and then of course Raspberry Pi. All these things are ridiculously cheap. So I did check the specs. Arduino runs at like 20 megahertz or something like that, 20 hertz. I'm screwing it all up. But to get a VGA signal, I need 60 hertz. And so I need like an ARM, I need like basically a Linux on a chip. I really want a Raspberry Pi. And then at that point, I'm going to need to go really low level because I'm now going to want to get VGA signals. Now I'm going to go learn the VGA spec or something like that and go check that out and see how that works. And then I'm going to need some really low level stuff to pull those video signals off and then send it along. So then I can have a full open source stack. Of course, ironically, I've got a Mac here, so I have to go do this again on a Linux as well. But I would love to have a full open source Angry Birds playing robot platform, if you will. That's my manifesto. Very long way to answer your question, but for now, Arduino is great. All right, I think we're done then. Thanks.